Assalamualaikum everyone, I hope you guys are doing well. So in this video we are going to cover the one type which was left of permutations, and that was permutations applied to numbers. I know I'm very late for making this video, but it is important obviously, but it's not something that's tested very often. But from now on, inshallah, I promise that once soon as we're done with permutation, I'm going to start making videos on combination also. So let's get straight into it. So this is permutations applied to numbers. So these are the kind of questions where you have to make a certain number, okay? And while you're making that number, you have to make sure that the number may be even, it's greater than so and so, maybe the first digit is so and so, so stuff like that, okay? So it's like instead of restricting positions of objects or letters, we're restricting positions of numbers, okay? So let's see what it says. This is the first question. It says, find how many different numbers can be made from some or all of the digits of the number 1, 3, 4, 5, 7, 8, 9. So altogether we have 7 digits. If all 7 digits are used, the odd digits are all together and no digits are repeated. Okay, so how many numbers are we dealing with? We're dealing with 7 numbers, and in this case, we have to use all 7 of them. Okay, but the condition is that all the odd digits, which are 1, 3, 5, 7, and 9, are supposed to be together. So let's start by making 7 blanks. So 1, 2, 3, 4, 5, 6, 7. Okay. So let's put the odd digits that are supposed to be together in any order. Okay, let's put them in a box. So since these are 5, so that means they can shuffle amongst themselves 5 factorial number of ways. Okay, something that we have done previously. Now altogether, how many units do we have? We have 1 unit which contains all 5 odd numbers. Okay, and then we have 2 other units, in which place you can have 4, 8, or any number that is basically left. Okay, 4 and 8, yeah. So that means they can shuffle 3 factorial number of ways. Okay, meaning that you can have all the odd numbers first and then a digit and then the other, or you can have 1 digit first and then the odd numbers and then the other digit, and this way, they can shuffle amongst themselves 3 factorial number of ways. So let's work this out. 5 factorial into 3 factorial, let's see what that is. 5 factorial into 3 factorial, this is equal to 720. Okay, so that's the first part. Okay, now part 2. Part 2 says the numbers made are even numbers between 3000 and 5000. Okay, so that means now we're not forming 7-digit numbers, now we're forming 4-digit numbers. Okay, and the condition is that the numbers must be in between 3000 and 4000. So we start by making 4 blanks. Okay, now if the number is supposed to be even, that means the last digit can be 4 and 8. Okay, the number will be even. And if the number is also supposed to be in between 3000 and 5000, that means the first digit can be either 3 or 4. Now this is what I like to call a conflict situation, because 4 can be, we have 1 4, and 1 4 cannot be at 2 places at the same time. So that means we have to decide where it's going to be. So how do we resolve this conflict situation? We resolve this conflict situation by fixing them in one place at a time. Okay, so how do we do this? It's very easy. So let's duplicate this. What we're going to do is we're going to fix 3 in the first place. Okay, so if I fix 3 in the first place, that means 4 can only be in the last place. Okay, so we have 1 option for the first digit, and we have 2 options, one of the two, either 4 or 8 for the last digit. Now in between, notice that we started off with 7 digits. Okay, 1, 3, 4, 5, 7, 8, 9. Now 2 of them are gone. Okay, 3 is gone for sure, and out of 4 or 8, 1 is gone. That means now we're down to 5. So in between, we have 5 options, okay, and we have room for 2. So that means we can either do 5 times 4 or we can do 5p2. It's up to you, whatever you want to do. Let's do 5 into 4. Let's see, what do we get? 5 into 4 is 20. 20 times 2 is equals to 40. But is that it? No, that's definitely not it. Remember that in the first digit, it's also possible that we have 4. Okay, so let's fix 4 in the first digit. That means now in the last digit, we can only have 8. Okay, so we have 1 option for the first digit, 1 option for the last digit. In between, once again, we started off with 7. Now we're down to 5. That means 5 into 4. So 5 into 4 is equals to 20. 40 plus 20 equals to 60. And that means the total numbers that you can form in between 3000 and 5000, such that they're even, are 60. Okay, using the digits mentioned in the question. Okay, now let's talk about part 3. So part 3 says the numbers made are multiples of 5, which are less than 1000, and digits can be repeated. Okay, so the numbers made are multiples of 5, number 1, they should be less than 1000 and the digits can be repeated. Because there is no restriction, that means we can have a 1-digit number, okay, just 5, it's a multiple of 5, there you go. So that's one number that is a multiple of 5 and it's less than 1000. Now what about all 2-digit numbers that are multiples of 5? Now in order to make sure that a 2-digit number is a multiple of 5, that means the last digit must be 5, that means we have one option, okay, and before that, before 5, we can have all the other numbers and the number is going to be a multiple of 5. So that means that's going to be 6 options, okay? So we can have 6 options here. So 6 times 1, that's equal to 6, okay? Now what about 3-digit multiples of 5, okay? So we're not going to go beyond 3 because if you go beyond 3, that's going to be more than 1000. So in order to make sure that a number is 3-digit and at the same time it's a multiple of 5, we have to make sure that the last digit is 5. So that means we have one option for the last digit. And for the first 2, remember we started off with 7. That means now we're down to 6. And after 6, we can have, okay, now here's the thing. Notice that the digit said, the question actually said, okay, no, correction. The question said that digits can be repeated. Okay, so that means a small correction. We're going to have 7 over here because although 5 is gone, but we can still repeat the digits. So that means this is going to be 7, not 6. Okay, and here, if we fix 5 in the first place, that means in the last place, that means now for the first digit we have 7 options, and for the second digit we also have 7 options because the digit can be repeated. Okay, so that's an error I made earlier. So 7 times 7 is 49. 49 times 1 is 49. So 49 plus 7 is 56. 56 plus 1 is 57, and I believe that is the correct answer. So we can make 57 numbers that are less than 1000 and happen to be multiples of 5. Okay, so I hope this is clear. Now let's move to the next question, which is question number 2. Let's see what this says. So question 2 says 9 cards are numbered 1, 2, 2, 3, 3, 4, and 666. Okay, all 9 cards are placed in a line, making a 9-digit number. Find how many different 9-digit numbers can be made in this way if the even digits are all together. Okay, so we have to make sure that all the even digits, regardless however many they are all together. And we are making a 9-digit number. So we start by making 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we have to keep all the even numbers together. So let's write down all the even numbers that we have. We have 2 2s, 1 4, and we have 3 6s. Okay, so let's put them in a box. Now they can shuffle amongst themselves 6 factorial number of ways, but notice that they're not all 6 unique numbers. Some digits are being repeated, so that means we will divide it by 2 factorial into 3 factorial. Okay, now what about the rest? So we started off with 9 numbers. Now 6 of them are gone. That means we're now left with 3. And the 3 along with the 6 even numbers that can be together shuffle amongst themselves 4 factorial number of ways. But remember, even though all the even numbers are gone, the remaining numbers are also repeating. What does that mean? That means from the remaining numbers, we have 2 3s. So when I'm doing 4 factorial, I will also divide it by 2 factorial to account for repetition. Okay, so if you work this out, and if you work this out correctly, actually let's do it right now. So 6 factorial divide by 2 factorial into 3 factorial into 4 factorial divide by 2 factorial, or simply 2 because that's what 2 factorial is. So that's equal to 720. Okay, now let's talk about part B. This was one part A, now let's talk about one part B. One part B says if the first and last digits are both odd. Okay, so once again we are dealing with 9-digit numbers, but the condition is that the first and the last, both the digits have to be odd. So let's start by making 9 blanks. 1 2 3 4 5 6 7 8 9. Now if the first and the last digit must be odd, that means we can have a 1 here, okay, and we can have a 3 in the last place, and in between we can have, so notice that we have one option for the first digit, one option for the last digit. In between, it's going to be 7 factorial because we started off with 9 digits, now we're down to 7. But from these 7, okay, from these 7, be careful that we have 2 2s that are being repeated, and 3 6s that are being repeated. Okay, 3 will no longer repeat because we have already fixed a 3 in the last place. So that means we will divide this by 2 factorial into 3 factorial. But here's the thing. There's no guarantee that, or you can say there's no condition that if you want to have the first digit and last digit as odd, they should be 1 and 3. They can also be 3 and 1. Okay, so you can have 3 as the first digit, 1 as the last digit. So notice that the first and last digit are both odd. Or you can also have, since there are 2 3s, you can have a 3 in the first digit and also a 3 in the last digit. Okay, notice that we have 2 3s. So it could be 1 3, 1 in the start, 3 in the end, 3 1, or even 3 3. So that means this formation will multiply it by 3, because for 1 3, 3 1, and 3 3, everything in between remains the same. It's just that the digits in the end, in the starting and the ending, can be different. So let's work this out. 7 factorial divided by 2 factorial into 3 factorial multiplied by 3. So that's equal to 1260. There you go. That's the answer. Okay, now let's talk about part 2. Part 2 says 3 of the 9 cards are chosen, okay, and placed in a line making a 3-digit number. So even though we're choosing them, we're making a number. That means it's still permutation, okay? Find how many different numbers can be made this way if there are no repeated digits. Okay, so we are making a 3-digit number and we cannot repeat any digit. So let's see how many unique numbers we have. So we have 1, 2, 3, 4, 5. So we have 5 unique numbers, okay, and we have to arrange 3 of them. So 5p3, which is equal to what? Which is equal to 60. Okay, the number is in between 200 and 300. Now this part is a little tricky. The number is in between 200 and 300. So what we start with is this. We start by making 3 blanks. Now, if the number is supposed to be in between 200 and 300, that means there's no doubt about the fact that the first number must be 2. Okay, so that means we just have one option for the first digit. And if the first number is 2, then naturally, whatever number we make, as long as it's a 3-digit number, it's going to be between 200 and 300. Okay, now, so we started off with, notice that we initially had 9 numbers. Okay, so we have 1 1, 2 2s, 2 3s, 1 4, and 1 2 3, 3 6s. Okay, now notice that a 2 is gone. Now, how many unique numbers do we still have? We still have, let's see, 1 2 3, 1 2 3 4 5. We still have 5 unique numbers for the remaining 2 spots. So that means in the second digit, we have 5 options, okay, and in the last digit, we have 4 options, okay. So even though you have picked a 2 in the first place, but you can still have a 2. That means the number can be, for example, 225. It can be 227, okay. So that's why, because we have 2 2s, we're considering that also, okay. And there's no point in double counting 3, because although we are going to consider a possibility where we have 233 and 266, but there's no point in repeating 3 here, because although we have, let's say, 2 3s, but in these places, it's only 1 3 that's going to come, okay? We're not going to consider 2 3s as 2 options. We're going to consider them as 1 option only, okay? So this turns out to be what? This turns out to be 20. Okay, now, notice that one thing that we don't end up considering when we're doing above is the fact that the number can also be 233, okay? We're using the digits provided, and the number is, once again, between 200 and 300. So this is one number. And another possibility is if the number is 266. Now, once again, notice that we're using the numbers that we're provided with, and this is another number that can also be in between 200 and 300. So altogether, how many options do we have? We have a total of 22 options, okay? So this was a little tricky, and I hope you guys have understood. Now, let's move on to the next question. So this is from October-November 2017. Let's see what this says. Find the number of different 3-digit numbers greater than 300 that can be made from the digits 1, 2, 3, 4, 6, and 8 if no digit can be repeated. Okay, so it's a pretty straightforward question. 1, 2, 3, 3-digit number greater than 300. Okay, so that means for the first place, how many options do we have? we can have 3, we can have 4, we can have 6, we can have 8. So that's 4 options. Now, how many digits did we start with? We started with 6 digits. Now, one of them will be in the first place. That means now we're down to 5. So we have 5 options for the second digit and 4 options for the last digit. And this is equal to what? This is equal to 80. Now, part 2. A digit can be repeated and the number made is even. Okay, so if you can repeat a digit, that means every time you consider the number of options, usually the following. The number of options for the following digit go down. That's not going to be the case here. So if the number is supposed to be even, that means we can have 2, 4, 6, or even 8 as our last digit. So that means we have 4 options. Now we started with 6 digits. We still have 6 digits. Okay. Why? Because we can repeat a digit. So that means for the first place, we have 6 digits. And for the second place, we also have 6 digits. Why? Because, for the first place, my bad, we still have to make sure that the number is greater than 300. So in order to make sure that the number is greater than 300, we can have 3, 4, 6, or 8 in the first place. So that's 4 options. In between, we can have 6 options because even though, let's say a 3 is placed in the first digit, we can still have it in the second or even not in the third digit because the number is supposed to be even, but we can have it in the second digit. That means we can have 2 3s. Why? Because a digit can be repeated. That's what the question says. So 4 into 6 is 24. 24 times 4 is 96. And there you go. That is the correct answer. Okay, I believe this is the last question. Oops, sorry. Let's see what this says. A security code consists of 2 letters followed by a 4-digit number. The letters are chosen from A, B, C, D, E. The digits are chosen from 1, 2, 3, 4, 5, 6, and 7. No letter or digit may appear more than once. An example of the code is BE 3216. Okay, so that means we got to have 2 letters first and then 4 digits. Kind of like some number plates where you have 2 letters and then you have 4 digits. Okay. Find how many different codes can be formed. So the condition is no letter or digit may be repeated. So that means if in the first place, let's say we have how many letters? We have 5 letters. So we have 5 options to choose from for the first place and 4 options to choose from for the second place. Now, as far as the numbers are concerned, we have, 7 options for the first, then 6 for the second, 5 for the third, and 4 for the fourth. Okay, let's see what that is equal to. That, if you work it out correctly, is equal to 16,800. Okay, so that's the answer to the first part. Now, part B. Part B says, find the number of different codes that include the letter A or the digit 5 or both. Okay. Now, instead of finding out the number of different codes that include the letter A or include the number 5 or even both, what we can do is, it'll be easier if we find out the opposite. That means we find out the total number of codes that include neither A or 5, okay? And we subtract that from the total, okay? It's like the probability of winning at least one match will be equal to 1 minus the probability of losing all the matches, okay? So we find out the exact opposite and we subtract that from the total. So the exact opposite of including either A or 5 or both would be including neither. So that's what we're going to do. We're going to do total minus neither A or 5. Okay. So let's see if we can, how many codes we can make with the condition that we don't use A or the digit 5. That means as far as the letters are concerned, we don't have 5 options anymore. We now have 4 options for the first place, 3 options for the second place. As far as the numbers are concerned, we don't have 7 options because we can't use 5. That means we have 6 for the first, then 5, then 4, then 3. Okay, if you work this out, and if you work this out correctly, this turns out to be 4,320. 4,320. Now from the total, which is 16,800, the question made us work it out for good reason. Now from the total, if you subtract 4,320, you get 12,480, which is the correct answer. Okay, so I hope it's clear now. Now let's do part C. Find the probability that the code is DE followed by a number between 4,500 and 5,000. So instead of immediately worrying about the probability, first let's find out the number of codes that we can have that start with DE and followed by a number between 4,500 and 5,000. Okay, and then we can always divide that by total. So if we know that we only gonna have D in the first place and E in the second, so that means There's just one option for the first and one option for the second. Now, if for the remaining 4 places, there has to be a number which is in between 4,500 and 5,000, that means for the first digit, we can only have 4. Okay, so that means we only have one option. Now, if you have to make sure that it's in between 4,500 and 5,000, that means for the second digit, we have to make sure that we either have 6, 7, or, sorry, 5, 6, or 7. Okay, 5, 6, or 7. 5, 6, or 7. Okay, so that means we have how many options? We have 3 options, okay? Because it's not just between 4,000 and 5,000, it must be greater than 4,500 and less than 5,000, okay? Or in between 4,500 and 5,000. So the first digit can be 4, has to be 4. The second digit has to be either 5, 6, or even 7, okay? Now, no condition for the last 2 digits. That means we started off with how many? We started off with 7. Now, 2 of them are gone. That means we have 5 options. And then we have 4 options for the last digit. So let's multiply this. 5 into 3 is 15. 15 into 4 is 60. So these are all the favorable outcomes, meaning all the possibilities where the code is DE followed by a number between 4,500 and 5,000. So what are we going to do with this? We're going to divide this by the total, which is 16,800. Let's see what we get. So 60 divided by 16,800. So we get 1 upon 280, which is the correct answer. And that's it. We are now done with this question as well. Now, there are some other questions which I haven't solved. Okay, I haven't solved all the questions, but I do encourage you guys to solve the remaining questions. They revolve around the same concept. And I hope the whole permutations is now clear to you, because we're done with all the concepts that we can possibly find in permutations. The next thing that we're going to start will be combinations. So I'll start posting videos on that soon, inshallah. So that's it for this video. I'll see you guys in the next one. Until then, take care. Allah Hafiz.